Good. Sumita, how are you?
Yeah, good, sir.
Where are you
Just,
from? Sumita, where are you from?
I'm in Finland currently.
Okay, you're from you are in Finland, but actually, where are you from in India?
Mumbai.
Okay, you're in Mumbai. Good. See, you are in Finland, but still you are dedicated. You are attending your sessions. That's good. Really happy about it. At least when I'm appreciating you, actually I find it, that whatever effort I'm putting in, that's worth when people attend the sessions.
Sir, in India, where are you based? Your office?
I'm in Noida.
Noida, okay.
Yeah. Sharik, welcome.
Thank you, sir, and good evening, all of you.
Good evening, but good afternoon from Ghana.
Okay, so our paid group, Sharik, Tawfiq, Abdul, they are already my learners for last 2-3 months, and they are champions in all these EDA and everything. But still, I appreciate the effort that they come in time even to attend these free sessions because they want to revise. Even though they're studying, with me, they are paying also, but still they have the commitment. They come even 9 o'clock or something. They come to revise, and that's the commitment that we need to see for ourselves. Abdul, as I said, Abdul. You'll see Abdul everywhere. Any session, anywhere, and Abdul is everywhere. I really like people who are hardworking, dedicated. It doesn't matter the course is free or course is paid. What matters is the effort, the hard work, the dedication, the commitment that you put in towards your career, towards your learning. That is more important. So we'll wait for just another 2 minutes and we'll start. And that's the reason I had changed the time from 8 o'clock to 9 o'clock so that more people could join. And that's what my survey said. I did it after a lot of survey. People said, the timing. So I took it from 9 o'clock so that more people could join it. But I don't see the change. If I do the hypothesis testing, between 8 and 9 sample and 9 to 10 sample, there's no significant difference. Thing is, people will go to Facebook, people will go to Instagram, they will say, I need help, I need this, how to do this. But when you're offered for something for free, when you are getting some mentoring, you're getting some guidance, then I don't know why people stop valuing. They don't want to attend. They don't want to give time. Good evening. I'm Troff. From Norway, right? Okay, another 1 minute and we will start. In the meantime, I'm sure you can see my board. Please read this EDA and the branching that I have done. Hope is visible. Can you see the table?
Yes, sir.
You can see the streak clearly, right?
Yeah, it is.
Yeah. Just read in the meantime. We'll wait for just another 1 minute to get started. Okay, guys, let's start. So, once again, I welcome you all. And this is the seventh session of our pro bono data science program. And as I said, all the videos have been uploaded on YouTube and our platform. And at least twice a day, I do send the updated PDF in the group, including the links to the platform and the YouTube. We have also ensured to show you that what we have been covering from the day we have started. I think August 31st is missing. I just added today. So this is what it is. We have the green one indicates what we are going to cover today. And this is the next session that we'll be talking about hypothesis testing. So these are the last two sessions. These are the next two sessions. And these are the past sessions that we will keep on updating. The next one, it gives you a lot of insight about the data as a certified data analyst. What do the organizations in the industry or in the market they expect from you? So this is like, people get more and more clarity. So today, we'll be talking about EDA or exploratory data analysis. So in any business, as I even spoke on the second session, without analysis, without EDA, you cannot even think of building a model. You cannot, it is like doing the basics and cutting, washing, or marinating your vegetables or cleaning your rice before cooking. Cleaning your vegetables is important. It requires a certain shape before you start cooking something. Similarly, whenever you have some data, you cannot directly jump to the models or building a model or start finding some pattern. You have to first explore the data. When we talk about EDA, exploratory, it means you are exploring the data. Whenever we visit a city or a new place or a hill station, what we do, we walk around, we explore those places. After exploring it for a certain number of hours, or depending on the number of days you stay, then you start realizing or start planning to visit those places, buy stuff, or do shopping. That's why in any data, EDA is very, very important. And that is what when we talk about data analyst or data analysis, that is the first stage of data science. After this stage, we generally move to the machine learning. And then we move to the deep learning, and subsequent analysis. But this is very, very important. When we talk about EDA, we can do it on R, we can do it on Excel, we can do it on Python, we can do it on many platforms. Each platform has its own limitation. Each platform has its own challenge and the advantages. So it all depends. Since this is a basic analysis, all the platforms will have this, because this is more from the statistical point of view. You're trying to explore your data from the statistical point of view. So the outcome cannot be different. A statistical formula cannot be different. Because whatever EDA you're doing, whatever EDA you're doing, what are the types of EDAs? Let's first understand this. One, we are doing univariate. Now, when we have already learned now what is variant? It's variable. So let's say my variable is sales. Okay, this is my data. 20, 30, 40, whatever. This is my data. So this is why if I'm trying to explore just the sales, this is my univariate, one variable. Now univariate can be non-graphical or it can be graphical. Second is bivariate. As the word says, bi means two variables. We are trying to explore some relationship between two variables. So let's say I have sales and I have profit, which we had seen on Tableau also. So we can do this univariate, bivariate on Tableau, Excel, or Python, anywhere we can do. So when we talk about bivariate, I have sales and profit. And I can see some sort of correlation, some sort of relationship between the two. That is bivariate. This can also be graphical and non-graphical. Third is multivariate. When I have more than two variables and I'm trying to see some sort of pattern, some sort of correlation, some sort of association among these variables. So that is multivariate. It's also graphical and can be statistical. Now let's understand that these EDA, what we are doing, univariate, bivariate, multivariate, graphical. Remember one thing, and that's the difference between a data analyst and just an analyst on Tableau. This graphical visualization is different from statistical inference. It means that your statistical inference can be a little different from your in graphic. You're just watching it, you're just viewing it. You may have some idea what is happening, but the validation, the verification can only come from the statistical inferences. Statistical inference will tell you, will validate your graphical visualization. Looking at the graph, if I say there's a straight line, my graph may say that this is a linear line, and my, let's say, graphically it shows as a linear line. Statistically, it will tell me that what is my R square coming from this. This we need to learn. What is the p-value coming from this? So now when I try to read this with help of the statistical inferences, then my EDA becomes complete. Otherwise, this is just a graphical presentation, just a graph for you, giving no meaning except for just having an idea that what is happening in your data. So when you add the statistical inferences to this, it actually gives you a complete information. Is this making sense? Is this clear?
Yes, it is.
Yes, sir.
Yes.
So now let's understand the types of when do we use and what type of tools. You don't have to mug up. It will come with a lot of practice and it will come with a lot of, when you want to just do an assignment, whenever you're doing some practice, it will come with a little bit of hard work, but more with practice. So if I go back to the sheet, see, if it is a univariate, and if your data is categorical, which we have already learned the types of data, so I'm not recapping the types of data, please. If it is a categorical data, a discrete, our EDA should be count or count percentage, very simple. Or it can be a pie chart in a graphical way or a bar chart. Bar chart is always for your categorical data when you have univariate, it's just one variable. When your data is numerical or continuous, you are finding the summary or the 5-point summary. We had discussed this during the second session. If you go and watch the video, you will find the 5-point summary where we are talking about the relationship mean, maximum, median, mean, mode, minimum, and then we call this as a 5-point summary. And we are trying to see, we call it center tendency and the dispersion. So that is a non-graphical. This is non-graphical univariate, where we are trying to find the minimum, maximum, mean, median, or mode, and we are trying to study the relationship, or IQ also, and we are trying to study the relationship of these measures on a given variable. Second thing is we are studying this is a center tendency. Here we are studying the dispersion, where we study the standard deviation, variation, range, quartiles, variance. So under the numerical, when your data, or when you're trying to study the univariate, this is the central tendency. This is the dispersion of the data. Then we are also trying to study the skewness. And Goddess, I don't know if you remember when we said, when we are trying to study the skewness of the data, if your mean is on the left of the median, your data is skewed to the left. Your tail will become thinner and thinner on the left. That is your data is skewed to the left. Hypothesis is that how many modes are there or how many peaks are there in your data. That is so. This is all these are univariate analysis as a part of the EDA. Another univariate with the numerical data is a histogram and boxlot, which we studied in detail during our second session. The powerful or the power of histogram boxlot in analyzing your data. These are very basic things, but these are very powerful tools. If you can analyze the data from these powerful tools, trust me, 50% of your business solution is known to you. But you must understand, if you watch my videos of second session, you will get most of these parts were covered. Now, if we go on the bivariate, now when you have bivariate, it means you have one x, one y. Here, you just have one variable, just one y. Here, you have one x, one y. If your bivariate, if your x and y both are categorical, we have studied this also, that we'll be doing the EDA using chi-square test. Chi-square test is more of a statistical test. It is, or we have studied that the tables, we are building the cross-tabulatory tables. We are trying to see the proportion. If you have, then we also prepare the bar chart, 2y axis plot, which we'll see sometime. This bar chart, we are talking from here. Under the bivariate again, if you have X and Y both as numerical, we study the correlation, and we had showed you the correlation matrix and the scatterplot matrix or the scatterplot. Very powerful tool again to understand your data at a glance. Now, if your data, if your X and Y, they're categorical numerical. If your Y is numerical, your X is categorical. You are using line chart or two-axis plot, or you also use the, if you talk about the test, statistical test, we use a t-test. Higher, when we go beyond this, then we'll be talking about ANOVA, we'll be talking about other tools which we use to study the data. So this is the tree of the branching of EDA on univariate and bivariate. When we talk about the multivariate, again, we are using regression, we're using logistic regression, linear regression, then there are many other tools that we are using. Here also, we'll study later encoding, binding, or binary. Any question on this before I move to the next step? Let's make it interactive, guys. Please ask questions. Any question? No question, should we move ahead? Sorry,
No,
any
sir.
question?
No, sir. No, sir. No, sir.
So let's understand this and let's see this on, we can see this on Excel, we can see this on R. So let me first show you on Excel so that you understand what it is, and then I'll take you to R so that you know that Excel itself is also fast and we can do a lot on Excel itself. So let me pick a data. This is my data. And let's say I want to see I want to export, I want to do a univariate for this column variable called overall service level. So I have to do univariate. So first thing I'm seeing that my data over here is continuous. If you look at this, let's follow this. My data is numerical. My data is numerical. I have to use 5-point summary. So how can we find the 5-point summary? If I go to my, if you go to Excel, if you go to data, you see data analysis. In case you don't have the data analysis over here, you can go to file, go to options, go to add-ins. Go to add-ins and you say Excel add-ins. Okay. Say go. You can see the analysis tool track. Tick that. Mine is already ticked. Once you tick that, say okay. you will see this coming over here. You will see this data analysis coming over here. Now, come to this is one part of it. They're very small. You have a lot of power to query a lot of things on the pivot side also. If I do the data analysis, take some time. Okay. Now, what I can say, I want a descriptive statistics because I'm doing a univariate for numerical data. So I want a descriptive statistics. You have any other options? You can see for histogram. You can see a lot of things you can do according, depending on what you want to do, what type of data that what type of variable that you have picked up. So I want to do this descriptive statistic. I say, okay. It's asking me input range. I'm taking this univariate, just this range. And I'm saying labels in the first row, we'll have the headers. Output range, by default, will take on the new worksheet. Or I can give the range here also, it doesn't matter. But let me take it on new worksheet. What I want the summary statistics. My confidence level for me, I want at 95%, or I can change it to whatever I want. I can change it to 99, but by default, it takes a 95%, which is the thumb rule. Universally, people accept 95%. Case largest, case smallest one, I'm not taking this. Okay, this is enough when I say summary statistics. So let's say okay. And you must do all these things in your role every day when you go to the office, whatever data you have. You practice on Excel, and then you can move to R. So now that I can see, this is my, I have found, this is my central tendency, okay? I'm just giving for your, this is a central tendency. This is my dispersion of data. Standard deviation, mean is a central tendency. Mode is a central tendency. This is a dispersion. Dispersion. How far you are from the average? How far is your data value from the average? How far is how much of deviation? All these things come in your dispersion. Then you have the kurtosis, you have the skewness. Range is again dispersion. Minimum is your central tendency. Maximum is your central tendency. So whenever we go for a univariate with a non-graphical, you can see this and you can look at the central tendency and the dispersion. Fine, everyone can do this. There's nothing tough in getting this, doing your analysis and getting it. Important thing is, how do you interpret this? Why is this 5 summary point or 5-point summary? Why is this very important and why is it very powerful? When we talk about 5-point summary, what do we study 5-point summary? Whenever you go for an interview, there's a very basic question. Any interview may ask you what is a 5-point summary or what do you do in univariate analysis? What do you observe? You must say that you observe the 5-point summary. Then they might ask you, okay, can you explain the 5-point summary? What's the relation? And that's where your basic knowledge will be judged. And they will understand that, okay, you're strong with basics. So when we talk about 5-point summary, we are talking about the mean, the median, we are talking about the mode, we are talking about Q1, which I'll explain to you. We are talking about Q3, We have to talk about IQR. We are talking about minimum value. We are talking about the maximum value. Trust me, guys, if you can understand the relationship of your data, by understanding this, half your problem is solved. You know what your data is talking about. You know your performance, what is happening. You can very well go in a review or a boardroom and you can explain to the management then what you can expect from this data in the coming future. Now that we know the mean is over here, right? Median is here. You have the mode Q1, we take the Q1. Or let's go to now the same thing, let's go on R. Very easy. Let's do the same thing on R. I take the same data. Over here, the name of my data is EDA practice. EDA practice. And I put a very simple command, very simple function. And that's called, Sharik, what is the function if I have to look at the summary of my data?
Summary function, sir.
Sorry?
Summary function, sir.
Summary, right? Very good. So I say summary and I put my data name and I say, let me write it for you. So that when you write yourself, when you type yourself, actually when you dirty your hands, you are becoming a better person. Don't always believe in copy pasting. Always dirty your hands. I strongly believe in dirty my hands. When I dirty my hands, I learn more and more. If I just believe in copying, pasting, actually you're not learning. Why? Because when you are actually typing, you are hitting your brain. You are activating your brain. When you are typing something, your brain is capturing it because your typing has some reaction to the action. When you're using your hand, your brain is capturing some data. That is why people say, write, when you write and write, you become sharper. Of course, typing is not as good as writing. If I write with a pen or a pencil, your brain you become sharper. Because brain starts capturing what you're doing with your hand. So, summary. Okay. This is a summary we get over here. And you can see, let me just take something of one variable rather than taking everything. I have taken over there, overall service level. Let me just take for one variable. I'm doing univariate. So this is what it is. 16.92 minimum. What am I getting over here? Minimum 16.92 here. So the outcome will be same. Minimum first quartile, third quartile. Okay. Now I know what mean is over here. I'm just let me not waste too much of time. You can see this. My quartile is equal to my quartile. I'll take from here. Okay. And I take the first quartile. Because you need to learn Excel also. It's very important. You cannot say just because I'm learning R and Python, tell you, I will not understand Excel. No. The market is looking for Excel as well. So IQ or the interquartile range is nothing but just third quartile minus the first one, that is interquartile deviation. You already have the minimum value, 16.91, the maximum is 99.7. So we have the 5-point summary over here. Mode is not available because there's no mode in this particular data set. The explanation part, why 5-point summary is important, that I will take in the next section. Right now I'm showing you going on the bivariate. This is my univariate on the non-graphical side. So if I have to do it on my graphical side, okay, I will Excel will take the can you please go on mute? It's not giving me the option of a graph today, so forget it. We will do it tomorrow. Now, if I have to do the univariate graphical, there are certain tools which we use here. Univariate, we use histogram, boxlot, skewed paradoxes. So let's see the histogram and boxlot. Again, very, very important and very, very powerful tools for exploring your data. Very powerful tools. I can do the histogram here also. Let's do the histogram. Univariate, always continuous data, remember. Here in Excel, we have to create range. These are limitations. On Excel, these are the limitations that you have right now. Let's use a very, very simple Excel data analysis. You'll have a lot of limitations. If I can say Pareto, cumulative percentage, chart output, okay. So it's given me a histogram with a Pareto. Okay, it's given with a Pareto, but forget this Pareto line right now. Okay, forget this cumulative. I had explained this also, I think, in my last session or something. Please see about the Pareto, or maybe people who attended my session on Saturday, the people who are attending my session, live session, the paid session on Saturday, Sunday. From this group, people are attending these sessions also. Of course, for free, I don't charge. So I think I had explained the Pareto on I had explained the Pareto on Tableau. Now I recall. The Pareto was explained on Tableau. So you look at this histogram, the blue one. This is a univariate graphical analysis, EDA. Similarly, we can do the box plot, and I will explain these why they are very powerful. Maybe in my next section. If I do the box plot over here. Why I'm teaching on Excel right now? So that you don't say, you know what, I don't know R, I need to practice Python, I don't know. Why? Start practicing on Excel right now. It's okay. So if I say box plot, I'll say the box and whisker. You have the histogram also here. And I say, okay. Oh, sorry, it's selected wrong. It's selected wrong. There's a box plot, which we can see here in R also. R gives you with a lot of colors, a lot of options. Python also gives you with a lot of colors. So here we see the box plot, multiple box plots at a time. We can see the box plot over here. Here. We can see the box plot again. This is the univariate EDA. And this box plot, I think I explained all my sections are saying they're very, very powerful tool. Very powerful. It gives you a lot of clarity, a lot of visibility about your data and what your data is talking about. What your data is saying, how much variance is there, what you can do, what you can understand about your data from this box plot. It gives you a lot of clarity. This is what it is giving you the 5-point summary. The 5-point summary is related to this. So if you can understand the box plot, and if you can explain the box plot, you are already good at, majority of the EDA part. Box plot, histogram, scatterplot, all they are very powerful tools. These are called basic tools of quality, but they are very powerful tools. And provided you know how to interpret, how to use them. So this is a univariate. When you take up, it's numerical. Now, let's read this again. We have seen the histogram, we have seen the box plot. Now, when we have categorical and categorical, that's called a chi-square test. Chi-square test, I will show you when I open the categorical data. In the data which I'm training you on right now, it only has the numerical data. I have the categorical data, I can do that also, but let me not mix it up right now. Here, bar chart, when I open the only categorical and categorical, I'll show you the bar chart also. Now we come to the bivariate. When we have the bivariate numerical, it says correlation scatter plot. And again, very, very powerful. We talk about correlation, and I think we had discussed a lot, but maybe some of you have joined later and you have not watched the video. You must watch the video. That's the reason why we are doing so much. When we talk about bivariate and this is my X, this is my Y. I'm using numerical data. It will always show you some correlation. Your correlation, or what we call, is also called a scatter plot. Your data is scattered. And somewhere you can see, if you plot this line, you'll see a straight line. Maybe your data points, they're not very close to the line, but this is the best fitted line that we're talking about. When we have two variables, numerical, it's called a scatter plot. Scatter plot talks about, it says, it shows the correlation. It shows the correlation between two variables. Here it's showing me the correlation between two and more variables. But here right now I'm talking about bivariate. That's why when I say bivariate, because I'm just using two variables right now. If I have categorical data, the bivariate, that is y and x both are categorical, and when we're using the chi-square, we don't remember this thing. We don't call it correlation. We always call association. So whenever we talk about bread and butter, bread and butter, we always say the bread and butter are associated. They're not correlated. They are associated. Whenever you have both an x and y as categorical data or discrete data, we always say your bread and butter are associated, not correlated. When I say the price of bread and price of butter, the price of butter, they are correlated because price is a numerical type of data, a price. So when these two are, when we plot them, they are correlated. The price is correlated. If we talk about bread and butter, they are associated. People who buy bread, they buy butter. It means the bread has an association with butter. Price of bread and price of butter are correlated. So remember thinking when to use a correlation, when to use the word association. And all these are basic questions, guys, basic fundamentals, which people normally ask you during your interviews. I've seen people, they know, they will tell you, okay, what is the machine learning, what is data science, what is the boxlot? But when they ask you such basic questions, they literally fail. So, if you are learning EDA, people will say, okay, EDA, I know bivariate, I can use a boxplot. But if they ask you, then what is a correlation, or what is the difference between a correlation and association, people fail to answer this. And if you fail to answer this, the interviewer, they understand that your fundamentals are not strong. You have learned from somewhere, but you don't understand your basics. Your basics are not in place. And no company will accept you if your basics are not in place. So this is the bivariate that we are talking about. Actually, during 1 hour, 1.5 hours, it becomes difficult to explain everything, okay? I mean, I cannot explain everything in so much of detail, it will become like 6 months training, which will be quite difficult for me to explain. Why I'm explaining, I'm giving you an idea that how important all these tools, the basic tools are, why it is very important for a data analyst, how you're going to interpret this. But of course, I cannot teach you on detail. I cannot get into the depth of it. But I'm giving an idea that whenever you go for any training, whenever you're choosing a training, whenever you're choosing a method, you must keep all these things in mind. The basics, the concepts. Now, the histogram, boxplot, EFC. Now again, categorical, I'll talk to the chi-square in a separate session or the next one. We are talking about the correlation. This is a bivariate and a scatterplot. So, scatterplot I showed you, and I'll show you again how a scatterplot looks like. This is a histogram on R. If we talk about a scatterplot, let's say, all these are functions, trust me, very easy. So don't get panic, don't get into panic because no, you're just doing a code. No, it is like Excel. You just put it, you practice it, and it becomes very easy. Maybe you can ask Sharik. Sharik, are you there?
Yes, sir.
Sharik, you also just started with R, you started studying with me for last 2-3 months. Are you finding R very difficult? Or now you are, your hands are set now?
Not so hard, sir, but it's required of only on practice if you do
Yeah, so
something on that.
yeah, since you're studying with us now for a long time, for 2-3 months, your practice on R. So you do realize that is more of a practice, and if you practice it regularly, even after 2 months or something, you know what you need, right?
Yeah.
Okay. So that's what I'm just trying to send this message to the team over here who are attending the session, that don't look at the code and get into any surprise. It's very, very easy. Very, very easy. So this is a scatter plot, just look at these things. Okay, let me show you on 1 or 2 plots rather than showing you everything. So this is a bivariate, because I'm showing you bivariate. So let me just put a color also. Okay. So now I put 2 variables and a scatter plot. Let's expand this. Okay. Or let me copy this. Let me put it on my board. This is a scatter plot on when we talk about the bivariate. It shows what is the relationship, what is the correlation between 2 variables. Here it shows a positive correlation, even though it's not a very strong one. So there are 3 types of correlation that you will always see. And you can watch all my videos, a lot of videos where I talk about correlation. If I have this, let me come to just hold on. if my correlation, this is my X, this is my Y. If my correlation, if this is my 0, 2, 4, 6, 8, 10, this is 10, 20, 30, 40, 50. This 2, this is 10, 4, 20, 6, 30. If I'm forming a straight line, it shows that as my X increases, my Y increases. This is called a positive correlation. Yes, since it is a straight line, I can see that both are increasing, both are changing the same ratio. So we can say this is a strong and positive correlation. If my data, if my variables, again, 0, 2, 4, 6, 8, 10, 10, 20, 30, 40, 50. If with this, it is 50. If my line is coming somewhere, is coming this way, this is a negative correlation. This is a negative correlation. This can also be positive. It can be a mild, can be a weak, depends on the how straight the line is. But this is a negative correlation. This increases, this drops. There can be, when this line is flat, or when you have too many data points scattered here and there, there's no correlation. There's no correlation. When we talk about correlation, it is indicated by R, small r. Small r. And when we talk about, when we study linear regression, and when this r becomes a r square, when we call this r square, how it changes, what does it indicate? How do we form an equation? How does it start predicting your data? That is where, when this r is squared, when we start learning linear regression, then my predictive modeling starts. How does r square and forming an equation in linear regression, how we start predicting our numbers. So that will come in linear regression, or when we do the predictive modeling, the logistic regression, linear regression, we will study the R square in linear regression. So this is the one bivariate correlation. Now, categorical and numerical on the Z test, ANOVA, all the hypothesis testing. This is a hypothesis testing, which anyway is already my plan to cover the next week. You see this, 14th September, we are going to start with the hypothesis testing, which is the basic and the pillar of any data science or data analysis or statistical analysis. Hypothesis testing is the basic as the pillar, and you have to understand this throughout your life. So anyway, on Thursday, we are going to cover this. So here we have seen the scatter plot. Now, we can see this even without a plot. Even we can see this with number with the statistics also. This is also very, very important. This explains a lot of, it gives you a lot of insight on exploring the data. It gives you a lot of insight. It's a very powerful tool to do a lot of analysis, a lot of building model. Your model can be built if you can understand it, and is very easy, as ABC to understand. Very easy. It's not wrong. I said, I always say, data science is not a rocket science, or data analysis is not a rocket. It's not a rocket science. I never found it a rocket science. It is just that we have studied mean, median, ratio, proportion in our grade 7, 8. It's just that we have not practiced. There's a scatter plot which you saw in B1B bivariate. Here we have multivariate. I have all my variables over here. All the variables over here also. This is my mirror image. You can see this 1, 1, 1, 1. This is a mirror image. It shows how strongly one variable is correlated with other. How strongly. This is R, which we talked about, R. Negative, positive is not about the magnitude, it is a direction. If it is a minus, it shows a negative correlation. Negative correlation. If it's a plus, it's a positive correlation. So this minus is not a magnitude of this R, it is a direction in which is a negative or a positive correlation with these variables. So this is called a correlation matrix. This is a correlation matrix, which is again, when we talk about multicollinearity, of course, as I said, I cannot explain everything in all these sessions. I'll have to teach you for next 6 months. There are a lot of things, very basic things, which are in the deeper part of it, how they use, why they use, and how it builds your model, how it gives, helps you create a better model for you. Okay, Sharik, are you there?
Yes, sir, I'm here.
Can you just explain just 1 or 2 lines that when we are building a linear regression model from this, why do we see this correlation matrix? What is this telling us about the independent variables? Can you just explain 1 or 2 words, sentences, very short?
Sir, basically in correlation matrix, if there is a strong correlation between variables or predictors, that means there is a dependency. That that when we building the model, we remove multicollinearity.
Yes.
If there is not correlation or no highly correlation between variable or you can say predictor, that means the variable or predictors and independent, which means there is no multicollinearity. That's why we
So
always try to remove the multicollinearity.
yeah, so from here we are trying to validate the assumption of independent variables. We call them independent variables, right?
Right, sir.
So when we call all these as these variables x's, they are called independent variables. So we can see from here whether all my variables are independent or not by looking at the multicollinearity, which I'm not discussing over here. Okay. So this is what Sharik was saying, that when we look at the multicollinearity, it actually tells us whether all these variables are independent or not. They must be independent. Only then your model will be right. So what is independent variable? What are predictors? All these things we will learn, but again, I said, no, I cannot cover so many things in 1 day or 1 week or something. It will take me a lot of time because there's a very short duration session and just twice a week. So there's a lot to cover. So this is a correlation metric. So we have covered 1 part of the EDA. My next session, I'll be covering the categorical part of the EDA. And then you will see everything on R again, and you can practice. If you practice, it is like a tips. It's not tough, very easy. You can practice on R, you can practice with me on Python. You can practice with yourself on Excel, any platform that you wish to use. But in EDA, you have to be very strong in EDA. This is not the end. This is not the end, okay? You can go on ARC and say, there is a library called Data Explorer, and use this function of Data Explorer, create this report. It'll give you everything on its own. It's creating. It's creating the report. Let it come. Yeah. Right? Yeah. It says data profiling. In EDA, we also call data profiling. This is a basic statistic. How many rows are there? How many columns are there? How much is the missing value in your data? It gives you everything. Here, it's giving you the missing values. It's giving you the data structure. What are the variables? Number of rows. There's a missing data profile. There's a univariate distribution on the histogram for each variable. There's a bar chart. There's a univariate again graphical QQ plot. Very, very important, very important to understand the QQ plot. Correlation analysis that I just showed you right now on R. This is your correlation analysis. You can do it on Excel also. It's very easy. You go on Excel and you say, go to analysis. You go to see correlation. Okay. Input range. You cover everything from here to here. And labels at first row. New worksheet. Okay. And I say okay. You can see I'm getting the same thing over here. Only thing is not colored. Okay. Excel is also giving the same thing. I can see the mirror image. Give the same thing over here. You can learn this on Excel also. It's not tough. So on this part, on the Explorer that we were seeing, so once you use this library called Data Explorer, it gives you, and also you can use this library. There's another library in R. Python also you have Explore. Explore will also give you a lot of part on data analysis. And this is primarily when you're learning data science, this is very important. And all these things will come once you understand the interpretation of these QQ plots. I will teach principal component analysis. It will take some time. This is also very important. Which is called PCA or the factor analysis. Another very, very important, and this is called, the library is called Explore. If you explore this, it will also again give you a lot of your analysis, the basic analysis. I won't say the target is over a service level. With the team leaders, I can see the box plots again. And that how, if all my team leaders, the performance of all my team leaders, they look similar. They look quite similar over here because all my box plots are there overlapping. And I can see the sizes also. So I can see that all my team leaders are performing on the same stage. If I see the correlation between either resolution and this service level, you can see how it looks like. You can see that in my data, which is the strongest variable, which is affecting me to affect my model, which will decide my why, which will decide my solution, which will decide my improvement, which is the strongest one. I can see over here. Here, call offered is the strongest variable in my entire data, which can affect my improvement, which can affect my change if I'm going for a project. Then ideal resolution. So this gives you this is called explain tree. This part of the EDA, and it gives you clear visibility that when you're going to build a model, when you're trying to improve the solution and give some solution to the business, you must keep these things in mind. Very important. This is the way you can create the visibility, you can understand the data, your analysis will come into picture. So this is called explore. You can see you see your view over here, you can see your data over here. This is called explore, which we will learn, don't worry. It'll take time. There are other libraries called pivot, R pivot. They're like a pivot of Excel. This is a library called R pivot, and we can run the pivot. R pivot is very intuitive. We don't need to always remember. I think I'm using this R pivot maybe after 1 year or something. But because I want to use R pivot, I'm telling R into something. There's something called R pivot. The moment I say R pivot, it's giving me an option. It means R is very intuitive. Python is very intuitive. R pivot. My data name, practice. Okay. Got it. Here, it's giving you a pivot table. Right now, I must know how to use it. The table. You want to make a table, or you want to make a heat map. You want to make a bar chart. So you must understand for a bar chart what type of data you need. You want to make a line chart, you must understand what type of data you need. You want to make a scattered chart, let me make a scattered chart. I know that I need to view numerical data. Right? So I take the average of service level. This, and I take call off. Okay. See, it's so easy to create a scatterplot over here. It becomes so easy. And I can see there's some correlation. If I want to make something else, I want to make a bar chart. So I have a bar chart. I must have one categorical data. I must have one categorical data with a count. So let's say I have team leaders. It's giving me a bar chart. The count of team leaders in my team. It's very easy. It's like a pivot table that you make on Excel. I'm making over here. Okay. Is it sounding tough or easy? Any questions so far? Is it very tough?
No, sir.
You're saying no because you have been practicing a lot. Jane, John, Sam, is it sounding difficult, easy, or is it a rocket science?
It's not rocket science, but we have to learn many things.
Yes, of course. You need to practice a lot.
Exactly.
Vinny, I just saw you now. Sorry, welcome. Who's VR? Who's VR? Vinny, are you there? Guys, if you guys log in, please. If you people are logged in, please stay focused, pay attention, no? Otherwise, just logging it doesn't make any sense. Vinny, are you there?
Yes, sir.
Are you getting it? I think you
Yes,
didn't come in
sir.
time. I think you didn't come in time, right?
Yes, sir.
So that's the reason I changed the time so that more people come in, but I still don't see the participation. People are just
Thank you
want to
so
join.
much.
No, people just want to join a group. And people are so interested. You know, I've seen one thing. People are so interested in joining a group. You tell someone, okay,
Sir.
yeah,
Hello,
Tell me.
Mr. Nupra. Here we are active while we are learning, sir.
no, I know you, Abudin, I know you are active, you are learning. I'm not talking. I'm saying there are around 225 people in this group. I just imagine, and there are just 8 to 10 people. So you ask them to join a group. I mean, as if joining a group is like increasing an appraisal or getting a salary. So interested in joining a group, but then I don't see the level of interest, and that's the reason people are not finding jobs. People are not being able to learn because that level of interest, the dedication, commitment, the priority is not there. It's just because my friend is doing data science or he's got a job. Okay, when I want to do, but when you're getting an opportunity, you're not showing that level of interest. It's not a priority. And I'm not saying you people are there still, but this is the trend of the market. This is what I'm observing. Anyway, that's your career. My job is to help you. My job is to support you. My job is to mentor you. And it all depends where you want to go, where people want to go. And guys, thank you so much for your time. And we will catch up on Thursday. I'll upload the videos maybe by this, today itself or maybe tomorrow morning. And we'll catch up again on Thursday to learn more and more. Okay, guys?
Thank you, sir.
Sam, are you
Good
there?
night.
Samansuri, are you there?
Thank you, sir.
Thank you very much.
Okay.
Thank you, boss.
Yeah, bye-bye.
Okay. Okay. Bye.
Thank you, sir.
Yeah, bye.
Bye.